One, two. Alright, hey guys, so welcome to this stream. If you're watching this after it's been recorded, that's cool. And if you're watching this live, that's even cooler. If you have a YouTube account, just chuck your questions and stuff in the chat box next to you, and I will get the comments as they come in, I guess. So we're just gonna wait about probably another 5 or so minutes. So if you guys want to go and grab something or whatever else, that's cool. Um, but this is going to be more of a theory talk and a kind of how to solve problems in general and how to solve programming problems. There's not going to be too much technical programming in this thing. If we get some time at the end, so this is going to run for about an hour. So if we get some time at the end, then for sure, then we'll go into some code examples. But I'm going to try and do some decent analysis of the problems that you'll face should you become a programmer. So that's where that's basically going. So yeah. Um, so what are we gonna do here? All right. All right. Cool. So just. All right. Cool. That works fine. All right. So you guys can just yeah, chuck your stuff in the sidebar. So what we're going to go over today is we're going to go over some scenarios and stuff, what can happen, what can't happen. How do you approach a problem when you're basically given fuck all understanding of the problem itself? Yeah. Alright, so start in about a minute or so. I am just going to quickly do something, which I promised I would. By the way, if you guys have IRC, you can catch me on Freenode. If you have any questions after this or during it, you can just join Web Social, where I'm an operator. So, um, yeah, that's always an option if you guys want. I'm just going to be waiting. If you're watching this after why I'm waiting so long, there's some people who really wanted to watch this from IRC, so I'm just waiting for them to come in. So sorry about the delay. All right. Let's do this. So, okay. Welcome to this talk. So, let's go to the next slide, I guess. Been staring at this one way too long. So, first things first. Programmers solve problems. Programmers should not be creating problems. So often you're presented with a scenario, whether it's coursework or whether it's in the real world when you are working as a developer. Often you're presented with a scenario where there's a problem and the client has a desired outcome. For this, I'll refer to everyone who issues the task as the client, just to keep it simple. So essentially, a client will come to you and they'll say, we know nothing about computers and we know nothing about anything to do with that, but we have an idea of what we want and we want to achieve it, right? And it better be bug free, or else we're not going to use you and you're a terrible developer. So you have to think, do I want to take these jobs? But let's just say you do. Right? And you're a brand new programmer. And you're probably freaking out, and you're probably, still in the university mindset of how to solve problems. Well, that's a problem in itself. New programmers often take the completely wrong approach to solving the problem, and even worse that I found is that universities actually often fail to emphasize the correct way, and in fact often emphasize implicitly the wrong way to do things. Don't resolve a problem, and there should be a hyphen in there, so that's terrible English by me, but don't resolve a problem. Okay? If you're resolving problems that have already been solved by other developers and other people in the world, you're just wasting your own time and resources and money. Now, why do I say this, right? It seems like a blatantly obvious point to make. Like, who cares, right? But the thing is if you come from a computer science degree background, often you'll just find that there's two kinds of things you do, right? The first thing that you do is you will essentially start from scratch and you'll write something that's been written a million times, whether it's a JSON parser, a graphics engine, doesn't matter what it is, right? You will end up writing the exact same thing that's already been written. Right, and you'll be told you need to do it yourself because it's a learning experience or whatever. Okay, and that's fine. And the second thing is that it'll either be that or you just get a slab of code to copy paste, and you'll learn fuck all. So don't resolve problems. It's a terrible habit, and if you actually end up rewriting already written code, you'll more often than not have thousands and thousands of open tickets against you in the real world, basically saying, like, what's going on, there's bugs here, bugs there, and it's simply because, one, you don't have the time or the resources to complete the task. If there's already a solution, use it. If there's a partial solution, combine it. There's absolutely nothing wrong with reusing other people's code and adding to it to make sure that, it suits your needs. And the final point I'll make quickly is don't create another problem. What I mean by don't create another problem is you've already been given a problem that you need to solve for your programming, right? So the client might, we're going to get to a scenario in a second, but the client might, want you to do task A. You don't want to end up creating task B, C, D, E, and F just to complete task A, right? You don't then want to create extra problems for yourself. And often what will happen is if you follow the university approach to development and development life cycles, you'll end up in an absolute shit heap. Alright. So here's an example problem, and we're going to probably spend the next 15 minutes just thoroughly going through this problem. Okay, John works 60 hours a week as a purchasing manager for a company he calls Lazy Inc., or we'll call Lazy Inc., right? He spends 20 hours of his week entering purchase orders into a company financial system, right? Now, there's the first issue, but we'll go on and I'll explain how this all works. He often runs into serious human errors because he has dyslexia. The company is now faced with a serious dilemma. Either fire John or lose all of his experience, or implement a business process that helps him work more efficiently. John needs to scan these documents in, and sometimes he has to have them come up in the financial system, as well as do manual data entry. So essentially, he needs to be able to scan the document in, and it automatically goes into the system. Right? Now, how to analyze the problem like a beginner. And what do I mean by that? I mean, there are different ways of analyzing a problem that's presented to you, right? So, your experience will very often dictate, unless you have some kind of weird natural ability to problem solve and to think about a problem in a certain way, you will often problem solve the wrong way. How does a beginner problem solve in programming, from my experience? A beginner often starts with the completely wrong approach. They say things like, I'll need to use C++, I'll need to use a unique pointer, or I'll need to use pointers for memory management. My SQL will use the datetime function to implement this. I can multi-thread processes to make it faster. Right. Why is this the wrong approach? Right. If you might ask, well, why is this wrong? This is the wrong approach for so many reasons, but the most important reason to understand is that you don't yet understand the problem itself, and you are trying to implement a solution to the problem that you don't yet understand. Oops. The intermediate way to solve the problem. This person basically looks at the problem ahead of him and is still thinking about the implementation. However, he's thinking about the implementation in a much more abstract way. He's thinking about the implementation in a sense that he's trying to efficiently solve the problem. But we're not up to that step yet. An intermediate way of thinking might be a GUI will be built that will improve the time to enter data into the system. I will use optical character recognition libraries to scan the documents, and this will be integrated into a form. Now, I'm not saying that this isn't part of the software development lifecycle, because it obviously is. However, we're not up to that yet, and that is a key trip-up point for a lot of beginner and intermediate developers. Okay, so how do you actually solve this problem? Think about it like an experienced programmer. An experienced programmer doesn't give a shit about the programming. What? You might say, what? Well, the end goal is to have all of the purchase orders in the financial system error-free. That's the first goal. This will be a partial manual process. So, I need to have a way of the person putting stuff into the system. Okay? I need to have it so that the person can put in purchase orders that they would otherwise do manually. The system will be able to bundle multiple purchase orders into a single order. Now, I don't know if you can yet tell the difference between this and, say, I don't know if you can tell the difference between, say, this and a beginner and intermediate problem-solving approach. But the approach taken here is to solve the business problems rather than solve the implementation problems. Because if you start solving the implementation problems before you've even tried to solve the business problems, you're honestly not understanding what you're needing to even implement. So jumping into code before you've even understood the problem is a really, really bad idea. And you're often going to lead you to very, very painful sorts of scenarios. TLDR, implementation is not analysis. So when you're analyzing a problem, sum it up, you're not implementing things. You're analyzing the business processes. You're analyzing the processes that have to happen. If you're writing a game engine, you're analyzing the final end result that you want to produce. You want to get a piece of paper and you want to draw something on the piece of paper that looks like a game, right? And you want to say, that's where I want to be once this progress is finished. Once this development cycle is finished. You shouldn't give a fuck about the language. Now, from my experience at university, it was like this. Everyone was hellbent on a single language. In my case, it was FPC. The language was the thing you were learning, and everything else came second. Now, there are over 150 programming languages. There's probably even more and more and more programming languages that I've never heard of. The programming language is just a tool. It doesn't really give you anything amazing, right? Like the programming language is not important. Yeah. Now, one thing that I think is really taught badly all across the board, and you kind of, there's few people in this world that really get this, and I guess the ones that come from hack culture kind of got this more. Don't get caught up in the hype train. It might go choo-choo for now, but eventually it's just going to die. I guess a good example of this is Node.js, and a lot of people will shoot me for saying this. 18 months ago or so, Node.js was the next thing, right? It was going to be the next messiah, the next coming of Christ for programming. It was going to solve the world's problems, kick ass, and then not even take any names. It just didn't care, right? It was that good. What happened is that Node.js died. Well, let me rephrase that. Node.js didn't die. Node.js has just kind of lulled. It's not dead. People still use it, of course, but it's not being shoved up everyone's, nostrils, and I can't smell it every day of my life anymore. Look for languages that are currently supported and that have been supported for a very long time and that suit your needs. If you don't search for languages that aren't currently supported well and don't suit your needs, all that you're doing is simply picking up the wrong tool. Now, a really good example that someone once told me is this. If you're hell-bent on using one specific language, or someone tells you to use one specific language, and you don't feel like it's the right language, and it's not the right language for the job, essentially all you're doing is hammering a nail into a piece of wood with a saw that's moving, right? So if you've got an electric saw and you hammer the nail into the piece of wood, you're going to get really injured really quickly. It's just not a good combination. Not that I know that by any means, but, So, an example of that might be using C++ to write a financial management app is just stupid. Okay? Now, let's differentiate here. A financial management app is different from a financial processing backend. You don't need to know what the garbage collector is going to do, right? It's just an interface where you push data around to a backend. It's nothing amazing. It doesn't need to be super duper fast. But the same thing applies. Don't write a game engine in C# or Java. And I know that people who will watch this afterwards will say, fuck you, Java's amazing. It's comparable to C++ in its speed and blah, 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 blah. Let me throw up everywhere, okay, and jump off the Java bandwagon. There's times when you need fine-grained control, and there's times that you don't. Be careful to pick the right time to pick the right thing to do. Visual Basic is not a programming language. If you're thinking about using that, let's just not, okay? However, I will say, at the expense of my own joke, all of these languages that are in the .NET family end up compiling down to MSIL, which is the Microsoft Intermittent Language, Microsoft Assembly. So, at the end of the day, it's just about readability. It's a horrible language, though. But the ultimate question remains, does the ecosystem relate to the work that you're doing? So you need to ask that question, right? And a good example of this has been for me, I've just finished writing a massive financial application. Right. Now, there are web servers you can write code for the web in C++. I could have chosen PHP, and I could have chosen Django with Python. But I chose C# with MVC and Razor. Simply because the data transport in MVC Razor with C# is just unbelievably it's unbelievably efficient to program in. You've got entity framework, you've got just so many different things that you just don't get provided to you nicely within any other real framework. I know that there are a lot of PHP frameworks out there and stuff, but I don't wish to get into that talk and that debate. So Plan your code in your head from back to front, never front to back. This is something I tell a lot of people that I do tutoring with. When I really felt like I was becoming a really confident programmer, what really changed for me was the fact that I basically did a 180 with my thought processes, right? I didn't go to the problem and say, what's the code I need to write? Okay? I said, what's the end goal and what's the general overview? Okay, so, I mean, if you can imagine, it's kind of like putting a funnel upside down. Put the most important thing in first, and then everything will slot into that most important idea. Consider the final bit of code that completes the processes for you. What does the process require to be completed? So, for example, let's just say I have a function, okay? And let's say the function takes some parameters of a custom type. We'll call the function complete process. It takes two parameters. It takes an object of tn and it takes an object of nt, right? And they're just two custom types. It's not important what they are. Now, what I'll often do is I will actually go and build that function first, and such that I know then what my data needs to be. More advanced than that, what I'll do often is I will build the largest classes first. So, for example, if I know that at the end of the day I need to produce a form on the internet that has 50 bits of data, and I know what those bits of data are, I don't give a shit about the implementation just yet. What I'll often do is I'll often create a data structure and a data model that represents that form. Then I'll go back, and it's super easy to work back from that process of, okay, we know what the data has to be at the end of the day, so now all we need to do is just simply work out the implementation for that. Now, something that if you're at university, you probably won't have much experience with yet. You may sort of if you're in third or fourth year, but you definitely haven't had a real kind of professional experience with this yet. Unless, if you've done open source development, then kudos to you. You probably have a lot of experience with this, and probably more experience than you'll get in the corporate world. But code collaboration requires you to write in a certain style of programming. Excuse me 1 second. Okay. So, be generic, but don't just abstract the fucking hell out of your program. So, a really good example of that is I work in a development team of about 4 people at the moment. Now, we all collaborate on one project. 2 of us mainly work on one project at the same time. Now, we don't want to end up writing the same thing over and over again. So we abstract things out, and we create essentially core functionality that then can be extended. Now, in C# and Java, you will call these interfaces or abstract classes. In C++, these are abstract classes, and you can create pure virtual functions and all those kinds of things. In PHP, these are abstract classes. But at the end of the day, you need to create reusable code that you can use for multiple different processes and things. And without sounding like a fucking memeing twat, base class all the things. Think about your inheritance structures very carefully. Code like art, but with a shitty time constraint. Sorry, code is like art, but with a shitty time constraint. Artists get time to paint their pictures, and they really get time to just rework over and over and over again. If you see the Mona Lisa was reworked hundreds and hundreds of times, and we know this by X-rays and other kinds of imaging of the painting. Now, the reason that I think that it was redone over and over again was simply because an artist is never happy with the first draft, right? It doesn't matter what other people think, the artist is honestly never happy with the first draft. And it's that iterative process that gets them to a kind of silver lining. And programming is absolutely no different. The only one real difference with programming is that you have time constraints that are just completely unreasonable. In the ideal world, the first draft of your code is never your final copy. It's kind of like writing a story. In the real world, you rarely have time to finish class foo before someone complains it takes too long. Unfortunately, the way that deadlines and things are structured in the world of programming is everything should have been done yesterday. If your code isn't ready by yesterday, then it took too long to do and it wasn't worth doing. It's often a really big shock that I find that when we get new people who come in from universities, and I guess TAFE and whatever else, they've often been given extravagant amounts of time to complete very minute tasks, right? And they often find that when they come into the workforce and they need to do some development work with us, they really struggle to understand why this is a ridiculous deadline, and I really have this problem as well. I didn't understand why you would want to trade really good code to meet deadlines, but at the end of the day, the reason being is people are trying to make money. Your code is like a portrait; they have to sell it, or there's no point doing it. Open source projects have a very different line. Open source projects often have very, very, very much more iterative processes, and I guess more people will look at your code in that time. So you'll often produce much better code. Programming is actually a communal thing, I believe. I truly believe that the open source model for programming is pretty much the only way to really produce solid quality code. Now, open source, as in releasing to the public, I don't necessarily care for. I mean, I do it all the time because I have stuff to share, but it's not the only way. When I say open source, I mean collaboratively writing code, in a team, having other teams that know that kind of code style to review the code, all those kinds of things. You will develop your own style of programming. Gone will be the days where you can simply copy and paste off of a PDF and you'll reach the desired outcome. You really need to develop your own style of programming, and this will ultimately help you with becoming a more confident and more experienced programmer, someone who's able to create solutions to problems that don't really even exist yet, right? There's no wrong way of programming, and I want to stress that I want to tread lightly with that because there are bad things you can do, right? There are very bad things that you can do syntactically, design-wise, whatever else. But so long as you understand that the processes that you do and the things in which you're actually asking the computers to do, so long as you actually understand what you're doing, there's no real wrong way of programming. However, if your code is a clusterfuck, you should be told. Now, there seems to be this, I don't know, feelings, kind of huggy feels kind of thing around the place with new programmers, and they get easily offended when you say things like, holy shit, your code is terrible, fix everything in it, right? Like here's 50 things that you can fix in your code. And they go, but I wrote this is mine, right? Like, what the hell do you know? Okay. Now, there's something really important to take away from this, is that myself, as of someone who's been programming for 10 years, I still make tons and tons of mistakes. I still write bad implementations of things. I still do, bad programming patterns at times. But I can often justify them. And I understand, okay, I've done something terrible, but this is why I've done something terrible, and these are the repercussions of doing this terrible thing. New programmers do terrible things and think that it's a good thing, and that's the difference. And I'm always very happy when a senior programmer, someone who is much more experienced than me, comes along and tells me, "Oh my god, what did you do?" Right? And then argues with me. Because we get to open a dialogue. We get to open a really constructive dialogue. And I won't always be right. Like, and I'll always be, I won't always be the one who comes out on top, and that's fine. That means that I've learned something. Programming is ultimately about learning new things. It's also about learning how to learn, and I'll get with that in just a second. And finally, just for this point, with code is like art. Comment, comment, comment. Did I mention use comments? Please use comments and always comment your code. If you don't comment your code, two things happen when you don't comment code. One, if you're working in a team, you're going to get slapped upside the head. Just trust me on that, you will. Actually, three things will happen. Secondly, no one will be able to help you, and everyone will actively refuse to work on your code base. And third and finally, when you have to go and work on your code base 6 months from when you first worked on it and you haven't touched it, good luck deciphering what the fuck is going on. So, I tend to go a bit overboard with my comments, especially in open source projects. I try and write little stories and little scenarios for each code comment that I do, especially for things like method commenting and all kinds of stuff like that. Have your code reviewed. You write terrible code, and everyone does. University will have you believe that there is a point where you'll become a good programmer. Also, unicorns really do exist. The problem with becoming a good programmer, or thinking that you've become a good programmer, is that two things. One is that you stop learning. And programming moves so fast, and some practical examples of that are C++ 98 to C++ 03 to C++ 11 to C++ 14 to very soon C++ 17. From the time of C++ 98 to C++ 14, which is the current standard, the entire way that we program in C++ has completely changed, right? Writing C++ 11 code looks almost nothing like writing C++ 98 code. Sure, they both look like C++, but the processes and the actual implementations that we use nowadays are nothing like each other. One of the biggest dramatic changes from C++ 98 to C++ 11 is the implementation of static memory management. So basically reference counter pointers like shared pointer and unique pointer. These were offshoot in the Boost ASIO libraries, and it was finally time to put them into the standard. What it ultimately did was basically cause and force everyone to write better code. A lot of code had to be reviewed, and it had to be peer reviewed. A lot of my code had to be peer reviewed, in fact. A lot of my open source projects had to be peer reviewed. I also had to develop an understanding of what was happening now. What really was these shared and unique pointers doing? Now, I won't go into these shared and unique pointers because that's a language specific thing. But I hope you understand the point. What you'll instead be able to do once you've been programming for long enough is you'll instead be able to write code that both makes you feel comfortable and that doesn't make others want to fucking delete you. RMRF, if you're wondering, is the command in Linux to destroy something completely. And in case of collaboration, just delete the entire Git repository because screw you. Okay, so that's the end of the presentation itself. Now, I'm just going to quickly check something, and then we will continue on to some code examples. Alright, So what I'm going to be doing with you guys is I'm going to be going through some Qt examples. So we're going to develop a little miniature application here, and we're going to be developing a GUI application based on the scenario that I gave in the presentation. So I'm just going to be calling this John's Finance, and I'm probably sticking it somewhere I'm going to regret much later. Alright, so first thing I want to do, let's run this. So as you can see, we've got a blank empty window here. Now, as I said, collaborate, work, and don't redo code that's already been written for you. So, what am I going to do? I'm going to jump onto GitHub, and on my GitHub I have created some style sheets for Qt. Essentially, I'm not an artist, and these took me a long time to do because I'm in fact a terrible artist. But what these do is these style your application to look a certain way. Now, I personally was looking for the whole Metro UI kind of Visual Studio look, and so that's what I went for. Now, I often use this over and over again. So, with a simple copy and paste, under the MIT license, of course, so anyone's allowed to use this, and I'll link to my GitHub in probably shortly after this, is I will look for style sheet, and I'll just go here, and we'll dump a style sheet into here, and hit OK. And just like that, I've essentially saved myself 4 or 5 hours of development time, because I didn't have to develop the style sheet. So as you can see, we've got a blank form that looks like Visual Studio. Okay, so we're going to be developing this financial application, and it's just going to be super simple. It's nothing amazing, you know, and it's probably not going to do too much. Obviously, I'm not going to be implementing optical character recognition at the moment in C++ because that would take forever. Even using something like Google OCR, it's just not a fun process. But what we will be doing is putting some grids in and all kinds of stuff. So, if you guys have Qt downloaded, feel free to follow along if you want to do a bit of C++ with me. And we're going to be working out how to solve these problems in an object-oriented thought pattern. If you don't have Qt downloaded, I probably wouldn't bother downloading it now. I would go and download it after the video is completed and the video is live on YouTube. And you can basically follow along if you want to follow these developments. So what we'll do is we will grab a widget. We're going to grab a table widget, and we're going to set a layout on that. Cool. Alright, and then we're going to have a button. Alright, easy. So, let me stop here quickly. How did I come to the conclusion that I needed a grid and a button? Well, if we go back to the original scenario, and let me just scroll back here really quickly. The end goal is that John can use a computer system to enter data into the system. Right? That's the end goal. Now, I know that John will want to have to enter data into a kind of table or a spreadsheet and press OK, and then the data and business processes occur. So by that reasoning and by that logic, I have now been able to create some sort of interface based on that. And for those of you who are wondering, because I'm sure I'll get some kind of question about it, how do I have League of Legends on Linux wine and wine tricks and a bunch of other kind of wine hacks. If you want, I'll post a link to how I did it in the description below after the talk has been saved to YouTube. So let's go ahead and build and run this, and we'll make sure that we're all good. And as you can see, we've got a button and we've got a little grid system here. Alright, very nice. So let's go ahead and write some code. Now, the first thing that we need to do is we need to design some models. How did I rationalize that? I rationalized that we need to develop some models that represent some stuff, because we know that John is entering a purchase order. And a purchase order is a physical thing that contains a number of properties. A number of things that make up the definition of a purchase order. So let's create a purchase order. Next, and finish. Now, of course, because I'm a good boy, I will namespace everything. And we'll just call this namespace example. I don't really know. Sorry. Not in a super creative mood tonight. It's been a very long day. Now, I want to make this an abstract class, and I have a few options. I often choose to make this an abstract class by creating pure virtual functions. And the pure virtual functions in C++, if you're not familiar, are created with something like this. Now, I'm creating a base abstract purchase order because we're going to create some custom purchase orders that inherit from purchase order. Now it's time to design the model itself. So we might have a few things. We'll have double total, double GST, double XGST, I don't know. STD string, title, and don't ever use that kind of casing. It is terrible. I should be using camel case or something, but it's been a really long day. Alright, cool. So, essentially what we've got is we've got our base model here. Now, what we're going to do is we're going to create some things to... We're going to create some basic purchase orders based on this abstract model. So an example of that might be a sports purchase order. And the base class is going to be example purchase order. And we have to do some includes here just quickly. Cool. So, as you can see, we have a base class and we have a sports purchase order. Now, the reason we'll inherit from this is because we may want to extend this model. Now, what are things that they don't share? Things that a base abstract class do not share with the sports purchase order are things that are specific to the sporting purchase order itself. Cool. Okay. So. It's always important to get your const correctness. It really helps in larger projects, but I mean, it obviously won't matter for this one. But it's still good to have const correctness. Now, let's go back to our base class here. So we'll say. Whoops, actually, no, we won't do that. We'll say. Alright, so sorry about this, you're just gonna have to bear with me, just while I get this done quickly. So, let's go back to our sports purchase order. Alright, and I'm just gonna quickly build the code to make sure that we don't have any issues, and we do because we put our thing in a namespace. What's its issue? Ah, yes, we have to implement our base class. Oh, what is it doing? Undefined reference to. Sorry, this should be in a namespace as well. And it's going to kick up an absolute fuss now saying, I can't find any of those methods. What are you talking about? So. Oh, the base class doesn't have a. There we go. Righto, so, sorry about that. My brain got literally fried just then. Okay, so, already we're way too deep into the implementation to know what we're doing here. But, what we want to do is something pretty simple. We're going to add an event for this button. Go to slot clicked. So, oops. And we'll go with 4, and we'll say UI.TableWidget.set row count 4. Just quickly run this. Very nice. Okay, that works for me. As you can see, we've got cells here. Alright, so what we're going to do is we're going to create a sports purchase order. And what shall we do? We'll say each line represents a item in the purchase order. So we'll say alright, so let me just quickly do one more thing. So I've been a little bit cheeky there. I've kind of used C++ 11 before I even explain what that does, but I'm getting a little bit out of it, so really sorry about that. But essentially I've just deleted the constructor because we won't need it because it's an abstract base class anyway. So things that an item might contain are yeah, that'll do. That's pretty much abstract enough for me. So we'll say whoops. Alright, so we have to go and implement these, so I'll just quickly refactor them. Whoops. And we need to take a parameter here, so I'll say double const. Probably should have done this to begin with, but actually we'll just do it in here quickly. Alright, too easy. So, we'll just quickly do our returns in here. We'll say return. They should be const actually. Don't know why it didn't add them. Alright, so what we're going to do is we're going to return the properties of each one of these. So it'll just be return this dot width. Very nice, very nice. Okie dokie. So, next we're going to make a tennis ball class. So I'm really sorry that this takes so long, but it's just kind of so you guys can follow along after this is done. So, we've got a tennis ball class, and our tennis ball class will inherit from, you guessed it, item. I really hope that there wasn't. I may have somehow clashed with the standard template library or something. 1 second. Oh, actually, I do need that constructor. Virtual void. That's really cheeky, and you should honestly never do that because that's terrible design. But I'm trying to make it abstract, so. What's it having a whinge about? Hey. Either I'm really confused or my compiler is really confused. Anyway, I'm running like really over time, guys. I definitely will follow this up next time. The main part of this was the first part of this talk. But I hope you guys can kind of see how you work through these processes. The second part was really terrible. I'm really sorry about that. It's just been an enormous day for me. So, yeah, basically, I'll post up when the next one's going to be. The next one will be purely code. So if you're interested in that, then come watch that. And yeah, I hope you guys enjoy, guys. Cheers.